Okay, so I've got another example here. This one is going to be the future value of an investment. You've probably seen this formula before, or maybe used it in a high school math class or something. This is the formula. So we're saying that the future value of an investment, like let's say you have $1,000 that you want to invest, maybe from a tax return or some kind of other windfall, and you want to know how much money that'll be worth in, say, 20 years or 50 years or however long you want to leave it sitting there in the investment vehicle. So the future value of that investment will be worth the present value, the $1,000, say, that you're putting into the bank or the stock market, times 1 plus the rate, the expected rate of return. So if you have a bank account with some kind of, percentage, guaranteed percentage of interest, that would be the rate of return. The stock market, they say, typically yields 10% gains over time, as long as you're willing to let it sit there for a long time. So, so that's the rate of return, 10%, for example, in the stock market. And then N is the number of years that money is going to be sitting there. So a fairly simple formula. I want to, before I get away from the screen, I want to mention that, in a regular math class, this, when you have the value next to the parentheses, multiplication is implied. That doesn't fly in programming. You have to use an asterisk for multiplication. So don't be careful of that. Okay, so here is the program. And remember our 1, 2, 3 approach. Step 1, get what you need from the user. Step 2, do your calculations. And step 3, display the result. So this is fairly straightforward. I want to point out a couple of things here, and I talked about this in the last video, how you have to be cognizant of data types. Remember that every time the user's hands are on the keyboard, that data is coming into your program as string data. And you cannot do math with strings. So that's a problem for this particular program. We have to make sure that as the user is entering the dollar amount, the investment amount in dollars, and the expected rate of return and the number of years, all of those need to be converted to numeric types, specifically float types, I would say. You could argue on the number of years. If we don't care about fractional years, maybe it's always going to be a whole number like 10 years, 20 years. But the present value and the expected rate of return, those must be floats, okay? Absolutely must be floats. But money is never an integer. And I see that with students a lot. That's just a common mistake. They know they need a number and they just want to grab that int. Always the int. That's like the go-to for a lot of students for numeric types. But money is never an int. Even when it's an even amount, there's still that potential for the dollars and cents, that decimal portion. So always float when it comes to money. So this is a money program. I'm going with float. The rate of return, I'm going to have the user enter as a percentage, like we talked about 10% with the stock market. I would allow the user to enter a 10, as in 10%. Behind the scenes, however, my program is going to convert that to a decimal. So I'll take the 10% and divide it by 100 to get a decimal format in that to plug into the formula. The formula wants a decimal, not a whole number on that, but it's easier for the user friendlier for the user to enter the whole number. So number of years, again, you could probably make that an int, but let's just go with a float in case it's going to be in there like 20 and a half years, or maybe they, want some kind of odd amount. Okay. So I have the data from the user, and now it's time to calculate. I want to point this out again. We're converting the rate to a decimal. Okay, user is entering it as a whole number, a percentage. I'm converting it to a decimal. This is a very common thing to want to do in programming. So we're saying the expected rate is whatever it is divided by 100. So that cuts the rate into it, and changes it to decimal basically, and then overwrites what was in there. Okay, this is such a common thing to want to do in programming that a lot of languages, including Python, have shortcuts for this type of line. And this would be the shortcut. You don't have to use it if you don't want to, but I just want you to be able to know it's there and recognize it. So these two lines mean the same thing. All right. So one or the other, we would take our pick. And again, if you're a beginner and it makes more sense for you to just kind of use the long way and spell it all out, that's fine. But you can do this as well. So that has the same result. All right. So anyway, I have changed the rate to a decimal, and now I'm ready to just plug it all in. Remember what I said about the multiplication? Okay, can't do this in programming. Got to spell it all out. So I have the multiplication there, and everything is just plugged in. Remember, exponentiation is the double asterisk. So now I'm pretty much home free. I'm going to display the result. I'm using F strings. Notice here, I didn't want to keep going way out to the right here. It's not a big deal if I did, but it just looks neater if you can see all the code. You don't have to scroll horizontally. I did have to use another F. I couldn't just like pick up the F string, on the next line without adding another F. So just be careful if you're going to do that. You might have to experiment a little with the F strings. So I will run this. Okay, we still have a little polishing to do, but this will work. So let's say I got $1,000 on my tax return. I'm going to put that right into the stock market, and I'm going to let it sit there for 20 years. Okay, so in 20 years, your initial investment, you know what, I'll put the word amount in there. Amount of $1,000 will be worth over $6,000, almost $7,000 in fact. I do want to show you how to manipulate the decimal precision, and I'll do that in a minute. Obviously this one, but even these, I'd like an even 20 and a, even though this was just a whole number, I still want it to look like real money with 2 decimals. So we'll do that. Let me see, your initial investment amount. Hang on, I'll add that first. Okay, so here's what you're going to do. And you know what, I'm not far into your book at the time of this video, but I have not seen this technique yet in chapter 2, but I'm going to show you. Here's a trick. Okay, so the number of years, for example. I want that 20 to have 0 decimal places. The number of years to have 0 decimal places. So here's what I'm going to do, right? I'm going to squeeze in here. I'm going to put a colon there, and then I'm going to put a decimal, and I'm going to say 0 because I want 0 decimal places on this value, okay? So that was a colon, a decimal point, and a 0 because I want 0 decimal places. And then I have to put the letter F, okay? That'll do it, okay? So now this one, the money, the present value, again, I want 2 decimal places here. All right, so same pattern. We're going to put a colon, we're going to put a decimal point, and then a 2 there because I want 2 decimal places, and then I'll add the letter F. Okay, one more time with the future value. Look at that. I don't want that long, ugly decimal. I'm going to get in there. I'm going to put a colon, decimal point, 2 because I want 2 decimals because it's money, and then the letter F. So we'll run it again. Okay, so let's see, $1,000, 10% in the stock market, 20 years to grow. Let's see how that looks. Okay, it looks great.